Solve the system by substitution or elimination. If the system is inconsistent or has dependent equations, say so. Here we have a system with 3 equations and 3 unknowns. Let's start by identifying these equations as number 1, 2, and 3. Now, let's key in on equation 3. Notice that it is missing the x variable. So I'm going to start by picking equations 1 and 2 and eliminating the x variable out of them. To do that, I'm just going to start by rewriting equation 1. 4x plus y plus z is equal to 11. Now I'm going to fix equation number 2 by multiplying it through by a negative 4 so that we can create a coefficient out here in front of x that's going to cancel as we add them. So negative 4 times x is a negative 4x. We'll get also a plus 4y, a plus 4z is equal to a negative 16. That was negative 4 times equation 2. Now we're ready to add. Our x variable does indeed cancel. We get also 5y plus 5z is equal to a negative 5. And I'm going to call this equation number 4. Now let's focus in on our original equation number 3 and this equation number 4. I'd like to solve this 2 by 2 system now. And I'm going to use the elimination method again. I'm going to eliminate the y variable. So let's multiply equation 3 through by negative 5. Thus, it becomes a negative 5y minus 10z is equal to 0. That was negative 5 times our equation 3. Now let's rewrite equation 4 underneath it. Let's add these equations together. Here we see our y variable cancel. We get a negative 5z is equal to negative 5, or z is equal to 1. So we found the value of one of our variables. Now let's go find the value of another one. I'm going to use equation number 3, which is y plus 2z is equal to 0. Let's substitute z equal 1 and solve for y. So y plus 2 times 1 is equal to 0. That's y plus 2 is 0, or y is equal to negative 2. Now we've solved for 2 of our variables. We need to solve for that last one, x. I'm going to choose equation 2 to do that. Equation 2 reads as x minus y minus z is equal to 4. So this becomes x minus, in place of y, put negative 2. In place of z, put the number 1, and that's equal to 4. That's not 4 times 2. This was equation number 2. So this becomes an x plus 2 minus 1. That's an x plus 1 is equal to 4, or x is equal to 3. It's always wise to go back and check these solutions in all 3 of your original equations, and a check does indeed verify that our solution set is x equal 3, y is equal to negative 2, and z is equal to 1.